Hi, welcome to this video. In today's video, I'm going to look at a very interesting series. It's called Taylor series or Maclaurin series, okay? It's more important and useful series because it's helpful and powerful for evaluating integrals and sums. Let's get started now. We have f of x. The Taylor series is written on this form. F of x equal to f of a plus the first derivative function of the function f at the point a, okay, over 1 factorial multiplied by x plus multiplied by x minus a, okay, plus the second derivative function of the function f at the point a over 2 factorial multiplied by x minus a square plus the third derivative function, okay, at the point a over 3 factorial multiplied by x minus a cubed plus the fourth derivative function of the fourth derivative function of the function f at the point a over 4 factorial multiplied by x minus a to the fourth until you get the last term, okay? The n derivative function of this function at the point a over n factorial multiplied by x minus a to the n, okay? Equal to the sum of f of a at the point a. We have the sum of the n derivative function of the function f multiplied by x minus a to the 2n plus 1, okay, over 2n plus 1 factorial as n goes from 0 to plus infinity, okay. This one is called Taylor series or Maclaurin series, okay. Now let's move on to continue with our proofs. Let's move on to take f of x equal to sine x as an example, okay. So let's set f of x equal to sine of x and a equal to 0, okay. So I'm going to plug this one into this expression. I'm going to replace a with 0 in this expression to see I will have f of x equal to f of 0 plus f the first derivative function of 0 over 1 factorial multiplied by x, because I'm taking a equal to 0, plus the second derivative function of 0 over 2 factorial multiplied by x squared plus the third derivative function of the point 0. So I will have f of 0, I will have third derivative function of 0 over 3 factorial multiplied by x cubed plus the fourth derivative function of 0 over 4 factorial multiplied by x to the fourth and all the way down until you get the last term, and all the way down to the last term, which is the n derivative function of 0 over n factorial multiplied by x to the n, okay. I have f of x equal to sine x. I'm going to take the first derivative function of sine x. I will have f of prime of x, f prime of sine x equal to cosine x, okay. And the second derivative function of cosine x, which is minus sine x, and the third derivative function of sine x, of minus sine x, which is minus cosine x. I'm going to the fourth derivative function of this function, which is minus cosine x is minus sine x. With this minus will become plus sine x, okay, and all the way down, okay. So now I will have sine x equal to, I'm going to plug this one into this expression. So we'll have f of 0, which is 0. The first derivative function of the 0. If I plug number 0 in the first derivative function, I will have number 1. I will have 1 over 1 factorial multiplied by x, plus the second derivative function into this one is equal to 0, because sine of 0 equal to 0. I'm moving on to the third derivative function, f of 0. If you plug the number 0 into cosine, it's giving you 1 with minus, we can minus 1, which is minus x cubed over 3 factorial. Okay, let's move on to the fourth one, the fourth derivative function. If you plug in the fourth derivative function into sine, is giving you 0. Okay, let's move on to the fifth one. The fifth derivative function is giving you cosine x. If you plug number 0 into cosine, is giving you 1. So if you plug number 0 into cosine, is giving you 1. So that's mean x to the 5 over 5 factorial, and so on. Okay, so this is equal, this sine x equal to the sum of minus 1 to the n multiplied by x to the n plus 1 over 2n plus 1 factorial, as n goes from 0 to plus infinity. Okay, let's move on to another example. Let's set f of x equal to exponential x as an example. Let's calculate the first derivative function of exponential x. I will have exponential x. The second derivative function of exponential x equal to exponential x, and all the way down. The n derivative function of exponential x is the same. This is the only function its derivative functions are the same as original. Okay, let's express this one as a Taylor series. F of x equal to exponential x equal to, I'm going to plug this one into this expression, f of 0 of this one, which is 1, plus the second derivative function, the first derivative function of exponential x, which is given as x over 1 factorial, plus the second derivative function of f of 0 of this one, which is x squared over 2 factorial, plus the f of 0 on the third one, the third derivative function of at the point 0 equal to 1 multiplied by this x cubed over 3 factorial, and all the way down to the x to the n over n factorial. Okay, this one equal to the sum of x to the n over n factorial, as n goes from 0 to plus infinity. Okay, this is the exponential. This is the exponential expression. I can put it here. This is exponential expression. This is the exponential function. This is the exponential function expression by using the Taylor series expansion. So I have done with this problem. Thank you for watching. I will see you in next video. Bye.